Hi everyone, welcome back. So we are moving on in Module 2, Topic 3. We are on Lesson 2. We are on page 317. And today we're going to start talking about unit rates. So we have an introduction to unit rates. Learning goals, we're going to write and calculate unit rates, use unit rates to solve problems involving unit pricing, better buys, and constant speeds. Use unit rates and unit rate language to make comparisons. Our term will be unit rate, which is going to mean per one for unit rate. We'll talk about that in more detail in a minute. So just a quick review, determine the unknown quantity in each proportion. So notice these ones are set up as proportions. Let me zoom in here a little bit, even if we just do kind of one side at a time. Let's look here at 1 and 3 first. So we need to go from 3 bows to a certain number of bows when 18 arrows goes to 162 arrows. So we need to figure out what are we scaling up by to go from 18 to 162. And so we have 162 divided by 18. Which tells us 9, so we are scaling up by 9. So this is a times 9 on both the top and the bottom, which remember that's a value of 1, so it doesn't actually change the value of the fraction here. It's really a ratio in fractional form. So 27 bows is our answer because 3 times 9 is 27. 18 times 9, 162. And 3 times 9, 27. Okay, down here, number 3. We're going from 8 shoes to a certain number of shoes when we know that 80 socks is an equivalent ratio with 1,600 socks or 1,600 socks. How many shoes would there be? So how do we go from 80 to 1,600? So if we divided them both by 10, we would have 8 to 160. So that's going to be a times 20. If you want, I can do that here on the calculator. So 1,600 divided by 80 is 20. So we're doing a times 20 up here as well. So we're going to get 8 times 20 is 160 shoes. So for this one, when there's 18 arrows and 3 bows, an equivalent ratio would be for every 162 arrows, there are 27 bows. And number 3, for every 8 pairs of shoes, there are 80 socks. So when there's 160 pairs of shoes, there's 1,600 pairs of socks. Okay, number 2 and 4. So going from 18 to some number, how do I go from 3 to 1? This time I'm getting smaller, so I'm scaling down by 3. So we're doing a divide by 3. So 18 divided by 3 is 6. So 6 arrows. So when there's 18 arrows for every 3 bows, an equivalent ratio is for every 6 arrows, there's 1 bow. Okay. And then we have 8 shoes is 80 socks. So if there's 1 pair of shoes, how many socks? So we go from 8 to 1 by dividing by 8. So here we're going to do a divide by 8. So 80 divided by 8 is 10. So there are 10 socks. I'm not sure if it's 10 socks or 10 pairs of socks. Either way, our answer is 10. So this one, for every 10 socks, there's 1 pair of shoes. Or maybe even 10 individual socks, there's 1 pair of shoes. For every 1 bow, there are 6 arrows. Or you can say it is for every 6 arrows, there is 1 bow. Okay, most of your previous work with ratios involved writing equivalent ratios, but you can also use ratios, specifically unit rates, to answer many different questions. So it says, how can you use unit rates to make comparisons and solve real-world problems? That's what we're about to do here on the other side. it says which one would you buy. So you go to the store. Marta and Brad go to the store to buy some laundry detergent for a neighbor. They see that the brand she wants comes in 2 different sizes. And it says, which should Marta and Brad buy? And to explain your reasoning. Okay, so here we see this kind in the red bottle has 26 fluid ounces for $9.75. And the one in the bluish colored bottle is 20.5 fluid ounces for $7.25. So let's just first kind of figure this out using estimation. We'll just kind of estimate here. So we could say for this red bottle, that $9.75 is pretty close to $10. So we could say 26 fluid ounces is about $10. So per ounce, if I divided that out, 26 divided by 10 is going to give me 2.6 fluid ounces per $1. So if I did 26 divided by 10, divided by 10, 2.6. If we thought about it using our equivalent ratios, if we go from 10 down to $1, we would do divide by 10. Here we're dividing by 10 as well. So it still works out the same. So for this red bottle, every $1 gets us 2.6 fluid ounces. And for the blue bottle, we have about, let's say 21 ounces. And it costs about $7. So if we divide that, 21 divided by 7 means we're getting about 3 ounces for every $1. Okay, so for this, which one is the better buy? Well, this one, our dollar gets us $2.6 fluid ounces. And in this one, our dollar gets us 3 ounces. So the blue one is the better buy. But let's try it using exact numbers. We'll kind of keep them the same here. So this is the red on this side. This is the blue on this side. Okay, so it's 26 fluid ounces. And it's $9.75. So what I'm actually going to do here, I'm going to do it 2 different ways. I'm going to do the 26 fluid ounces for $9.75. And I'm going to get the exact cost on that. So 26 divided by 9.75 gives us 2.6 repeating. So that's going to be about 2.67 ounces for every $1. And which is very close to our estimate. So we're pretty much on track there. But whenever we do a cost analysis, we always start with the money. So I shouldn't say always, we most always. So if we start with the money, we say $9.75 for every 26 fluid ounces. Then if we divide that, we do $9.75 divided by 26 fluid ounces, we get that it's 0.375, which in money will round to 0.38 cents. If we put a dollar sign, $0.38 per 1 ounce. So remember, when you just do this division, you are finding the unit rate. You're finding the per one. And then if I did this here with the blue one, the exact division would be 20.5 fluid ounces divided by $7.25. And when we divide that, we end up with, I'm just going to round it right away here, we get about 2.83 ounces per $1. So for every $1, we get 2.83 ounces. And again, that's fairly close to our estimate of $3. So now let's turn it around and do the cost per ounce, right? Because we're doing the dollar sign in the top. So that's the cost per, and then the fluid ounce. Remember, this fraction bar says per or for every. So that's $7.25 for every 20.5 fluid ounces. And again, when you divide that, you're taking it down to the per one. If I just did the per one fluid ounce right here, and we thought about scaling, I'm doing divided by 20.5. Here I'm going to do $7.25 divided by 20.5. So do you see how when we divide this, the numerator, the cost, by the denominator, the number of ounces, we are figuring out the unit rate, the per one fluid ounce, per one of whatever's in your denominator. So 7.25 divided by 20.5, just looking at it straight like that, gives us the same as if we're using the scaling down method. So we're still going to get the same number because we're still doing 725 divided by 20.5. So 7.25 divided by 20.5 gives us 0.35 cents per ounce. So $0.35 for every ounce. So we have, I'm just going to write it down here. We have, I'm going to write it like this, 38 cents per ounce. And this one is 35 cents per ounce. So, and when we used the estimation, we said that the blue one gave us more for our money. For every $1 we spent, we had more in the ounces. We had 3 ounces versus the 2.6. When we're thinking about the money, do we want our money number to be greater like we did here? The 3 was greater than the 2.6. Do we want the 38 or are we looking at the 35? So it's 35 cents for every 1 ounce, 38 cents for every 1 ounce. So when we're talking about the money and we want the best buy, we're looking for the lowest number. We would rather spend 35 cents for something than 38 cents. So the blue is still the best buy. We'll see you on the next video for activity 1.